interesting. So today I decided that I should start a new business, and this business I'm going to be selling tomatoes and onions. Now there's a special way in which I would like my business to operate. So just in case in the future you want to do business with me, then you have to understand a few things. So with me here I have exactly 3 tomatoes, and I have exactly 2 onions. So here I have exactly 3 tomatoes, and here I have exactly 2 onions. Now, there's a book which I'm going to be using to record this information. Now, in that book, I want to reserve space in that book. I don't want to waste so much space. So there's a special way in which we are going to be representing these tomatoes and the onions in that book. So now, as long as you are doing business with me, we are going to be representing tomatoes with letter X. So whenever I write X in my book, I'm talking about a tomato. Then whenever I write Y in my book, I'm talking about an onion. So it means that in our business, tomatoes are going to be represented by letter X, and onions are going to be represented by letter Y. So now, instead of saying 3 tomatoes, we're going to be saying 3x. And this side, instead of saying 3 onions, we're going to be saying 3y. Now, what exactly do we have here? We have 3x and 3y. If you want, you can just use the normal English. We are saying we have 3 tomatoes and 3 onions. So, this can easily be represented. Let us just write something so that we should be clear with what we are talking about. Now, before we write anything here, let us put on a mathematical cap. It seems like things have changed. We are now in the mathematical field. All right. So we have already agreed that the tomatoes are going to be represented by letter X. Then the onions should be represented by letter Y. So this is tomato, then this side we have onion. So letter X for tomato, then Y represents onions. How many onions do we have in total? So we have 2 onions. So instead of writing 2 onions, we're going to write 2Y, because Y represents the onions. And then this side, instead of writing 3 tomatoes, we're going to write 3x, because this x represents the tomatoes. Now, I want us to get the total number of the items which we have. So here, I have exactly 3 tomatoes, and this side I have exactly 2 onions. Now, what is the total of this? I guess it is impossible to add these because they are completely different things, right? Because what we have here, these are tomatoes, and what we have this side, these are onions. So if we say 3 tomatoes plus 2 onions, we cannot add these because they are completely different things. So, in mathematics, we say that if things cannot be added, they are unlike terms. But if things can be added, we say they are like terms. For example, here I have 2 tomatoes, then this side I have 1 tomato. What is the total? I can simply add because these are exactly the same. So here 2 tomatoes plus 1 tomato, we're going to have a total of 3 tomatoes. We can add. So things which are exactly the same are called like terms, and they can be added. And things which are not the same cannot be added, and they are called unlike terms. So now, when we have this, here we have 3x and 2 onions. We have 3 tomatoes and 2 onions. Can we add these together? We cannot add because they are not the same. So what we can just write is this. In mathematical statement, this means 3 tomatoes plus, meaning and, this is and, 2 onions. So this is the statement. This is how we can just leave it. because it is impossible to add things which are not exactly the same. So here we have 3 tomatoes and 2 onions. We leave it like that. We cannot get 5 because these are completely different things. But when we are talking about things which are exactly the same, for example, 3x plus 4x, like that. We know that this is 3 tomatoes, then this side we have 4 tomatoes. So if we say 3 tomatoes plus 4 tomatoes, we get a total of 7 tomatoes, like that. Then if again, for example, we're given that 3 onions plus 2 onions, we get a total of 5 onions. So these are exactly the same. That is why it is possible for us to add them. Now, in mathematics, it is very important to understand the idea of collecting like terms. Sometimes you can be doing a business where you have things which are mixed up. You have tomatoes, onions, all of them are just packed in one basket. So when a customer comes to ask for tomatoes, it will be difficult for you to start searching in the basket. So before you start doing your business, it is important that you separate those things first. You get all the tomatoes, you put them in one basket, then you get all the onions, you put them in one basket. So this in mathematics we call it collecting like terms. So let us try to write down a mathematical basket, then we try to collect the like terms. Right, so this is the mathematical basket where we have things which are mixed up. We have tomatoes and onions mixed up in one basket. Now, in order for us to do our business properly, we are supposed to separate these things. We get all the onions, we put them on one side, and we get all the tomatoes, we put them on one side. So the first thing that we are going to do here is to identify all the tomatoes. So here we have tomatoes, then also here we have tomatoes. Remember, when you are identifying, these letters must be exactly the same. So this letter is exactly the same as this one. So it means that they belong to the same family. So we're going to get the 2x, like that. Then we get this other one, the 4x. But when you are getting it, don't forget the sign which it has in front. So this 4x has a positive, so we get it together with its sign. So we have 4x. Then what are we remaining with? These also we put them together, the 4y and 2y. So the 4y has a positive in front, so we put positive 4y. Then the 2y has a positive, again we put 2y, like that. So what we have done here is we have collected the like terms. Now let us see if we can add something. Things which can be added are called like terms. So here we have 2x and 4x. So these are exactly the same. They are both tomatoes. So 2 tomatoes plus 4 tomatoes, we get a total of 6 tomatoes. Then this side we have the onions. 4 tomatoes plus 4 onions plus 2 onions. We get a total of 6 onions, like that. What about here? We have 6 tomatoes plus 6 onions. Can we add these? No, it is impossible. We cannot add because they are not the same. They do not belong to the same family. It is impossible to add. So the answer, we leave it like that. Now, sometimes the way we represent the terms in an algebraic expression can be a little bit confusing. You can think as if things are like terms, but they are not like terms. So if I wanted, I can represent tomatoes by letter x. Then I can represent the onions by x squared, like that. So this x squared represents onions, then the x represents tomatoes. So you can clearly see that this letter is different from this one. What makes these two different is because this one has a power on top and this one doesn't have anything. So they're completely different. Okay? So if we have an example, we can say 2x plus 4x squared plus 5x minus 2x squared, like that. Now, to simplify this algebraic expression, we are supposed to identify the like terms. So let us look for the tomatoes in this expression. So we have this x is exactly as the same as this x. So these are like terms. So we are going to get this 2x and the 5x to put them together. So we start with 2x. Remember that when you're collecting your like terms, you shouldn't forget the sign which is in front. So we're going to get this 5x together with the sign in front. So we write 5x like that. What are we remaining with? The onions. So the onions are the ones which have x squared. So this x squared is exactly the same as this one. So these two also, they belong to the same family. So we put them together. So we get the 4x squared minus 2x squared, like that. Now, what we have here is 2 tomatoes plus 5 tomatoes. We get a total of 7 tomatoes. So we write 7 tomatoes. Then this side, we have 4 onions. When we have 4 onions, we should remove 2 onions. Okay? So 4x squared minus 2x squared. We have 4 onions, we should remove 2 onions. We are going to remain with the 2 onions. Like that. Remember that when you're adding or subtracting, you don't have to tamper with the powers, because the whole of this thing represents a tomato, an onion. So if you tamper with it, you tamper with the power, it means that either you're cutting the onion or you're bringing in something else. So when you're subtracting, you just have to subtract the way they are, just look at the numbers. Yours is to focus on the numbers only. So this is our final answer, 7x plus 2x squared. Here we cannot add this because you see this x is not the same as this one. This x has power 1, but this x has a square. So they are completely different. We cannot add them and we cannot subtract them. So this is the final answer. Our final example. So we have 2y plus 3y to the power 3 plus 4y plus 2y to the power 3. Again, we do the same thing. We collect the like terms. Like terms are letters which are exactly the same. So we have this y and this y, they are exactly the same. So we put them together. So I'm going to start with the 2y. So we have 2y. Then this 4y has a positive in front. I'm going to get it together with the sign. So we write positive 4y. Then lastly, we have y to the power 3 and y to the power 3. So these are also exactly the same. So we're going to put them together. So we have 3 y to the power 3 plus 2 y to the power 3. So this 3y to the power 3 is the one which I've put here. Remember the sign also together with its sign in front. Then the 2y to the power 3 is this one which I just wrote here together with the sign in front. Now we can simplify either to subtract or to add depending with the signs which you have. So this 2y plus 4y, or 2 onions plus 4 onions, we get a total of 6 onions. Then this side we have 3 apples plus 2 apples. We get a total of 5 apples, like that. So this is the final example for today, and I wish you the very best in the exercise which I'm going to give you. Thank you very much for watching, and meet you in the next lesson.